Alright, we're going to finish out this section on volume with calculus, looking at things in 3 dimensions, but this time we're going to be doing something called working with cross sections. Just a quick review of some geometry stuff. We want to look at these shapes here out in front of you, but we want to consider how to find the area of each of them when all we're given is the base. So for a square, that's pretty straightforward. Let's just say the base was b, then the height is also b, and then the area is b squared. As we get into these other pieces, that's going to be changing a little bit. So if we say that the equilateral triangle, for example here, if the whole base is b, then half the base is b over 2. And thinking of this as like a 30, 60, 90 triangle, in which the relationships tend to be x, x root 3, and 2x, or it doesn't really matter what letter you use, but that height there is root 3 times whatever this short side's going to be. So this is going to be b over 2 times root 3 for this height. So then the area is going to be the base, the area of a triangle is half the base times the height, which in this case would be b times half the base times the height, which is b over 2 times square root 3. Now if I were to simplify all that, the area comes out to be square root of 3 over 4 times b squared. What you're going to find in each of these shapes is that you have b squared, or that base squared, times some type of constant. Just got to figure out what that is. So again, thinking about the whole base, in this case the whole base, it would be b, but just the radius, which helps us find the area of a circle, is b over 2. Keep in mind that this is a semicircle, half of a circle. So the area would be half pi r squared, and r in this case is b over 2. So doing some simplification there, area equals pi times b over 2 quantity squared. And if I were to figure out what that constant is, it's going to be pi over 4 times b squared. Whenever you see a right isosceles triangle as being your cross section, that means it's a 45, 45, 90 triangle. And most often you'll have it with the hypotenuse as the base, kind of creating this pyramid looking shape. That tells me that if this is my base, then what I really need to figure out is my height, because if I know the height and the base of a triangle, then that helps me find the area. So the area equals 1/2 base times the height, but I need to figure out what this height is in terms of the base. Well, if I split it down the middle, that creates 2 adjacent 45, 45 triangles. And that would make each of these sides b over 2, b over 2, and the height also b over 2. So this would simplify to 1/2 b times b over 2, or even more simply, the area equals 1/4 b squared. So that constant was just 1/4. Sometimes you'll have a rectangle as well, where the height and the base are related by some type of constant. So let's say here's our base and here's our height, but the height equals some constant times base. Whether it's a fraction or an integer greater than 1, a whole number greater than 1, it doesn't really matter, but there's some type of relationship. Well, we know that the area equals the base times the height. But if the height or the base is multiplied by a constant, then it's really just that constant times the base times the base. Because that height can be replaced with a constant. So that constant winds up being the constant that we're looking for anyway. So the area equals the constant times base squared. Keep this in mind as we go through each of these shapes today. We're going to derive them again as we go, but this is going to help us as we work our way through just this type of thinking. Okay, we have a solid whose base, that word came up again, is bounded by the circle x squared plus y squared equals 25. We want to take cross sections, so we're thinking cross sections that are perpendicular here to the x-axis of squares. Well, if this is a base of a square, then what I need to do is find the integral from a to b of my area of my shape. Now before we did this with discs, where the area of a disc was pi r squared. But in this case, we're looking at just other types of shapes as well. So if I'm looking for a base here, trying to figure out what that is, I also need to consider what my shape is, which is squares. So I'm looking for the base squared. And my limits of integration, well, if I'm perpendicular here, that means my direction of travel is in the x, which is what I had written here before. So my x starting point is going to be -5. My x ending point is going to be 5. I just need to define what that base is then. Well, if I try to find the distance between two curves, that's just the top one minus the bottom one. Then I need to define what is this top curve and what is this bottom curve. Both of them are defined by the circle. And notice that in the red here, we're going to have the top half of it and the green is the bottom half. So let's start with the red. The top is going to be this equation, but solved for y. So if I have y equals radical 25 minus x squared, that would be this equation, but just solved for y. The bottom, if we get a green color here, the bottom is y equals, that's kind of bright, let's do something a little bit darker. Y equals the negative square root 25 minus x squared. So here's negative square root 25 minus x squared, and on top was the other one, square root 25 minus x squared. So our base is just top minus bottom. The base is equal to that red one, 25 minus x squared, minus the green one, which is negative 25 minus x squared. Both of these in radicals. And since we have two negatives there, we can add them. If you have two of the same thing, that's really just saying 2 times radical 25 minus x squared. So that's our base. So if I wanted to find the volume is equal to the integral from -5 to 5 of 2 times the radical 25 minus x squared, which is my base, squared. This is my base squared. Why is it squared? Because it's a square, and I know that the area of a square is just the base times the base. Let's try one, but slightly different here. If we're looking at equilateral triangles, remember, if we're looking at equilateral triangles, we have a shape that's kind of like this. And we need to know the base and the height. The base is just b. Each of these halves is b over 2. And this height is the radical 3 times b over 2. And when we put all that together, we had gotten the area equals 1/2 base times height. Well, the base is just b, but the height is radical 3 over 2 times b. So then this came out to be radical 3 over 4 times b squared. But hey, we already know what b is. We know what that base is. So the only difference between the last problem and this one is this constant. So I just have to do the integral from -5 to 5. And we have a constant, square root 3 over 4, times that base, which is 2 radical 25 minus x squared dx out here, and squared up there because it's the base squared. How easy is that? Let's do another one, a lot like it. Semicircles. So if I'm looking at semicircles, I'm just looking at the top half of the circle. I don't really care about the bottom half. So this top half up here, let's see if we can get back to a pencil. We're looking at this piece here. The area of that is going to be half pi r squared. But remember, r is really half of our base if we're looking at this as a semicircle sitting up on top. So then the base, r equals the base divided by 2. So then the area is equal to pi times b over 2 quantity squared, which simplifies to, if we square both the top and the bottom, we're going to get b squared, and the bottom is going to be 4, so it's have pi over 4. So there's my constant. So again, I'm going from -5 to 5. My constant's pi over 4, and I'm looking for 2 radical 25 minus x squared, all quantity squared, dx. There's my volume. So let's look at what it would look like with isosceles right triangle. Quick reminder, with this type of triangle, that means that we're looking at something kind of like this. And what we did is we said, here's our base, but we're going to split it so that we can figure out the height. Well, that makes 2 isosceles right triangles here. It means this is b over 2, and so is this. And hey, so is this. The height is b over 2. So normally the area of a triangle equals 1/2 base times height. And in this case, our base is the same. It's just b. But the height is b over 2. That means that if I were to try to figure out what this would be, we'd have b squared, like we've had with the other ones, but it'd be 1/4 for a constant. So when I set this one up, we're going from -5 to 5. We still have the dx. We still have our base squared, which is 2 radical 25 minus the x squared. And then out front, we have our constant 1/4. That's what we're looking for. Let's see if we have any more of these. Ooh, we got something different. So now we're trying to find the volume of something that's bounded by the lines y equals x minus 4, 4 minus x, and we're going to do it with a couple of things here. Sorry for not having this organized, but here we go. So first let's plot this and see which one's top, which one's bottom, how we set it up, and all those kind of details. So start out with an x and y axis. I actually can pop up a grid here for us. Put it on top. Okay, so if we have an x and y axis, here we go. Put it right here in the middle. Here's my x-axis, or my y-axis, here's my x-axis. And I got 2 lines. I'll draw these in gray just so they stand out a little bit. We have x minus 4, so that's 1, 2, 3, 4 down here. So we have a line that looks kind of like that. And we have another line which is 4 minus x. That's going to look like this. And then we're also bounded by the line x equals 0, which is really just this axis. Go ahead and take that one back because we know we already have an axis there. So now I'm looking at this region. Now let's go ahead and color it in a little bit. Looking at that region. My base again is just that cross section from the top to the bottom. This is my base. So I need to figure out what that is. And my base is going to be top minus bottom. We'll call this the top. That's 4 minus x, and the bottom is equal to x minus 4. So the base is the top minus the bottom, which is 4 minus x minus x minus 4. And if we were to simplify this and combine a few things here, this negative distributes, so I'm going to have 8 minus 2x, because I got 2 negative x's, and this negative 4 makes a positive. So there's my base, 8 minus 2x. Then what I'm going to be looking at is my shape. I need to make squares, and the area of a square is just base squared. And we're going from A to B. So where do we start? Where do we finish? We start here on the axis at 0, and we finish at x equals 4. So we're going from 0 to 4. of the base squared dx. There's no constant because it's just a squared, or it's just a square. So then we're doing the integral from 0 to 4 of 8 minus 2x quantity squared dx. Now, I know that we can evaluate that, but I'm worried mostly about setting it up, just like we've been doing with this whole workbook, just for time's sake. Equilateral triangles. Again, a quick reminder. It looks like this. And we've also been noticing that we have a height here down the middle, and that height winds up being b over 2 because we say this is b over 2, this is b over 2 because the whole thing is b. The whole thing is our base. But then we make two right triangles, so this one's going to be b over 2 as well. Then the area of that, oh, wait a second. This is equilateral triangles. I was thinking right isosceles triangles. Let's stretch that out a little bit. Make it more equilateral. So we know that these are still b over 2 because the whole base is just b. But because it's equilateral in a 30, 60, 90 triangle, that changes the relationship. So this is b over 2 times the square root of 3. So the area of an equilateral triangle in terms of the base is 1/2 the base times the height, which is 1/2 b times the h is b over 2 times square root of 3. So when we simplified that, we got square root of 3 over 4 times b squared. So we're going to set it up exactly the same as before, except now we have a constant outside. So the volume for this one is equal to the integral from 0 to 4. But we got a square root of 3 over 4 on the outside, and we still have 8 minus 2x, our base, squared on the inside, dx. Now that we kind of know what the base is, we don't have to keep redrawing it, but let's take a look at a couple of more shapes. We got semicircles and isosceles right triangles here. So for a semicircle, alright, sorry about that hiccup. Just had to pause it for a second. You probably didn't even notice. But anyways, we're looking at these last two shapes, semicircles and isosceles right triangles. So first, semicircles, if we're looking at a semicircle where this is the base then represents the diameter. But there of a semicircle is 1/2 pi r squared. It's half because it's semi, it's only half of it. But in this case, r is equal to the base over 2, so it's going to be b over 2 quantity squared. Ooh, it looks like I missed something before, because this constant needs to be b over 2 squared times a half. That's going to be pi over 8. So I missed that on one of the earlier problems, pi over 8b squared. Similarly, we got the isosceles right triangles for that shape. We have a shape kind of looking like this, and this is one that I started to do, but it was getting a little bit incorrect. We know that the whole thing is the base. That means each of these halves is b over 2, or the base divided by 2. That means the height is also b over 2. Why? Because this creates another pair of isosceles right triangles up here, where these are each 45 degrees, and that's 45 degrees, and 45 degrees, and 45 degrees. A lot of symmetry going on here. So let's set up these pieces. We know that our top and bottom, top minus bottom comes out to be 8 minus 2x. That's our base, and we're always having our base squared. We're going from 0 to 4. The difference now is looking at the constant. For this one, it's going to be pi over 8. For the next one, it's still from 0 to 4. It's still 8 minus 2x quantity squared. Both of these are dx, by the way. But now the constant is, if we have the area of one of these triangles, it's half the base times the height. Well, half the base is 1/2 b, or b over 2, but then the height is also b over 2. So that's going to be 1/4 b squared. So this is just 1/4. Whoops, 1/4 on the outside. Easy, breezy, lemon squeezy.